Okay, my BattleBot designers, you guys should be familiar, or at least somewhat familiar with Fusion and have an account and be ready to do some designing. So I've set you up with some templates, some files in your folders. So hopefully you have access to this, which is our BattleBot Robot Rumble 2021-2022 folder, in which we are going to go ahead and design with. So I'm going to use the HammerBot template to get started. So if you open your folder, you should find a template in which there are probably two motors sitting in there, spread apart and constrained or jointed together. So I'm going to start with that. Now, if you left click and try to drag them, they will not move. I kind of randomly place them apart. You're going to have to make some changes to that based on how much stuff you're going to put in between them. So if you want to just temporarily turn on the eyeballs next to all of the things that are going to have to eventually fit into the robot. It's really not much if you don't have a weapon. You've got two speed controllers, two batteries, and a switch, a kill switch, and this turns it on and off. There's other things, wires, a lot of wires actually, and some a little tiny receiver, but I didn't put that in yet. And you're also going to want to make sure that your hands can fit in here to move things around, to plug in the little connectors that fit into here and things, and we'll get to that later. But remember that this stuff is going to have to fit in. So we're going to turn them off by clicking the eyeball for now. So I want to show you how to do some designing where we don't have to use as many dimensions as you normally would in an IED class when you're starting from scratch. So I want to show you where the joints are. So if you're opening it for the first time, it might look like this, where the whole tree system in the browser is closed or collapsed. But if you expand the joints, I named this joint Drive Motor Distance Apart. And if you right click and you edit that joint, you're going to notice that there's an offset distance in the Z of 15 inches. I can change that to whatever I want, 20 inches or 5 inches, or basically that's going to say how far apart those motors are, and I can make that change at any point in the design if there's not enough or too much room. I'm going to start with 15 inches and kind of begin my design and see what that leaves me when I start to put my batteries and all my components inside my design. So once that updates my graphics, I am going to begin. So I have two components already created for you, a top plate and a bottom plate. And there's only one thing in each of these. So I'm going to go ahead and I'm going to activate my top plate. Notice how these ghost away. And when I do that, I want you to notice if you expand the tree below it, there's a sketch down here in the history that I've already started. I would recommend that you begin on this sketch, and I'm going to tell you why. If I double click down here in my history, if you open up the sketches folder, you'll also see that that sketch exists. So if I start on that sketch, what I've done is I've projected the geometry of the motor onto the sketch, which is like creating a shadow of the hole in which we're going to be bolting the bottom plate, or top plate rather, to the motor. And I've also projected the edge of the motor, the shadow of the edge of the motor onto the sketch. So what I'm going to do is I'm going to draw a rectangle, and I'm going to snap, making sure that the little box symbol comes up when I click. And then I'm going to roll my mouse out and pan over to the right hand corner, and I'm going to snap to the furthest edge here because in my mind I'd like to design this plate to go the full distance all the way until the edge of the motor, and then I want to make sure that these holes come up as well. So right there. Okay, so the reason why I'm doing this is because when I finish this sketch, giving my computer a second to catch up, and I extrude, I'm able, always capture position anytime anytime that window comes up, I can extrude this sketch and I can include the holes that I projected from the motors. Now notice how all of my lines are black, meaning that they're fully constrained. Pick all this object, all these regions here, and I'm going to extrude this to a distance of 0.5, and that's because I'm going to make this out of polycarbonate. And if you go into the shop and you measure how thick the plastic polycarbonate material is, it's 0.500. Now I'm going to hit OK. Now, assuming for this hammer bot that I only want this plate to be this wide, I think that I'm okay. If I wanted this to be like a wedge bot, I could have made this rectangle longer. I could have also created a sketch on this bottom, and I could have added an additional rectangle snapped onto this corner. Let's say I wanted to make a wedge bot and I needed that top plate to be a little bit longer. I could have done that by adding an additional extrusion onto there. Now I'm going to use collinear to line it up with this edge, just like that. Now the reason why I'm using my constraints instead of dimensions for this is because, and now I didn't dimension this yet, I don't know how far forward I want the robot, but I'm going to activate my assembly now and show you why I did the snapping to the projected geometry and the collinear between these two edges. Let's say that I decide that I forgot to extrude this. Let me go back to my top plate and let me extrude that to 1/2 inch, 0.5. Looks like I got to go in the negative direction. Make sure you're extruding it all in the same direction. There we go. Okay, so now I have a bottom plate. I'm going to activate my assembly again. So let's say that I turn on my my batteries and I realize, when I place my batteries in there, and right now they're not constrained or anything. Let's say that I decide that I want my motors to be closer together. If I go and I edit this joint, by right-click, edit, and I change my offset distance to, let's say, 10, and I hit OK, watch what happens. Computing. Updating graphics. Sorry, my computer's slow. Everything moved with it. So this plate shrunk with the motors as the distance came together. So the projected geometry, which were just the shadows which were cast onto the sketch, it followed. So that's really important, because if we make any changes to our design, meaning like we move the motors closer or further apart, it's going to follow that geometry. Now I did not put any dimensions on how far forward this plate came, so that one is going to require dimensions. So I'm going to go back to my top plate, open up that sketch number 2, and you'll notice that this line is still blue. So I better figure out, how much further forward I want that robot to come. Maybe for now I'll put in 10 inches. And I can always edit that later, but there's only one dimension in this bottom or top plate, you'll notice. Everything else is driven by the projected geometry. Okay? Now, you'll notice when I go back to my assembly, if I activate it by clicking the radio button, if I left click and hold, I move this plate. Oops, don't do that. I'm going to undo. That's because every time you create a component and you go back to the assembly, we need to create a joint, meaning like tell it, are you locked to something? Should you be rotating? Should you be sliding? So after you create a component or you create a body, it's very important that you immediately create a joint. So what we're going to do is we're going to right away go to Assemble, and we're going to do an as-built joint, meaning directly as I build it, I want to create a joint so that it stays in place and I can't move it. So as built, I would like to do a rigid joint because this plate isn't supposed to move in relationship to the motors. So rigid is perfectly fine. I'm going to select the plate, and then I'm going to pick a second component that I would like to keep it locked together with. So I'm going to pick the motor, and I'm going to just say OK. It's a good idea. You'll notice the joints folder that a new rigid joint appears. Good idea, folks, that you name these. So a slow 2 clicks. Name them. Top plate locked to motor. And that's just for future reference. You're going to end up having a lot of these joints, and you don't want to get confused as to which one is which, just in case you have to modify it later. All right. Let's just make sure that once I've done that, that if I change my motor distance, that plate's going to move with it. Let's go crazy. Let's say 25 inches. It's going to, of course, have to compute my graphics because my computer is getting old, kind of like the designer here. We're going to update the graphics, and voila. I've got a huge robot. I don't want it to be that big, so I'm going to click undo. You guys should know this undo button. It's right here. It's the arrow to the left. Anytime you make a mistake, undo. So now I'm going to work on my bottom plate, and I'm going to basically do the same thing. Activate it. I already have a sketch started for you. Please use my sketch. If I open up the sketches folder, I can find it there, or I can just double click on the history and open it from there. And I'm going to draw a rectangle and start in the top corner of the topmost corner. Scroll out, in to the bottommost corner, right? Okay. And then I'm going to finish my sketch, let my computer catch up, and then I'm going to extrude it, making sure that the holes don't extrude. So that should be empty. If it accidentally you pick it, just cancel and try it again. So 0.5. Should probably tilt my world a little bit, make sure I'm going in the right direction. Yep, I'm going up. You might, if you're smart and you're thinking that I should probably project these holes a little bit larger than the diameter of the hole that's behind it, you're absolutely correct for clearance, but we do have drills and we can always drill those out a little bit more once it comes off the machine. That's fine. So I'm going to practice what I preach, and I'm going to go directly to the assembly, and I'm going to do an as-built joint so it doesn't move, because look, it moved. Undo. So I better immediately do an as-built joint. This to the motor. Now it's locked. Now it does not move. And I'm going to name it with a slow double click. Bottom. I can't spell. Bottom plate to motor. Here we go. Now these are solid pieces of polycarbonate, which will weigh the most, so we're certainly going to want to maybe remove some material or lighten them up. So at this point, I think it's time for us to look at the geometry of each of these components and think about, well, what can we do to make them lighter? Can we take out some triangles or some squares or some rectangles to lighten them up? If we're going to maybe put this battery, why won't you move battery? Sometimes it's a little clicky. Left click, hold to drag parts around. You might want to start thinking about placing these batteries into your assembly now and moving them around to make sure you have room. Where are they going to go? How are they going to sit? Are you going to have room to get your hands in there? Of course, maybe this plate comes forward a little bit more than what I have. If things are in your way and you can't see, you can temporarily turn things on and off by clicking this little eyeball. Okay, but if you'd like to place your batteries into the robot using a joint, I'm going to show you how to do that right now. Okay, if you're wondering how I'm easily orbiting, press the Shift key and hold your middle mouse rolling button at the same time, and you can easily orbit. So I'm going to spin it kind of upside down-ish, and I'm going to add these batteries locked to the robot. So let's assume that I wanted these batteries to sit somewhere on the surface of this plate here. This is actually the top plate. I don't know why I'm building it upside down, but I guess top, bottom, it really doesn't matter. Maybe it does matter, but for this demonstration it doesn't. So what I'm going to do is I'm going to go to Assemble. And in this case, since I didn't build the batteries in place, I kind of brought them in, I'm going to do a regular joint. And in this case, I'm going to go to Motion and make sure that I'm on Rigid. These are all different types of motion. Unless something is moving, you're always going to use Rigid. When things are in motion, that's when we get into these other ones here. But for the most part, if it's not moving, you're going to use Rigid. After you select Rigid, go back to Position, and this is how you pick things to move them around, to get them to where you want them to go. So again, make sure it's on Rigid, and then for Position, you're going to spin around and you're going to pick two different objects from two different positions. So I'm going to first pick the battery, and also as I'm picking it, before I click, I'm going to make sure that the pick point is, for this one, in the center. So this surface and then the center point. So this surface, and then make sure the center point lights up before I click. And by doing that, when I spin around and I find the surface that I'm going to be sticking it onto, you'll notice that this surface lights up and also the center point lines up. That means that the battery is going to go to this surface, and then those 2 points that lit up are going to touch. You can see that. Now, I don't want the battery to go there. From here, I can move it to position it by dragging the arrows, or if you wanted to type in like distances. If I don't like the orientation, like the angle, I could be like, all right, I want you at 0 degrees if you want the battery going that way, 90 degrees if you want it going that way. I don't know yet, so I'm just going to start like maybe going that way. Again, I'm not sure what I want yet. I just kind of want to place them on the surface to start. Again, I better name that battery 1 or something so I know what these joints are, so that when I move them later, I have an idea of what I'm moving. Do the next one, joint, rigid, center to center. And I think I did 90 degrees, so I should do this one at 0. Yeah. And I'm going to just move it over so it's not like on top of this other one. And then this is going to be battery 2. So as we move through this design, let's say I don't like where they're at. All I got to do is right click, edit joint, and then I can just move it over. Or if I like it more forward, I can just move it from there. And now I've just moved it by editing the joint. Okay. But again, I think actually where I placed them might be a good starting point. Maybe we can tuck them a little bit forward, possibly. All right, so we'll move them back. And I'll take the other one and I'll move the other one back as well. Edit joint, slide it back so it's flush, and hit OK. And there we go. Now we got 2 batteries, not very symmetrical, but for a demo video, hey, give me 5 stars. All right. You can do the same thing with the kill switch. Just turn on the little light bulb. You can do that for the speed controller, and there's 2 speed controllers. Now, you can see I put this flush, meaning, well, I mated it so that it's sitting right on top of this piece of plastic or polycarb. You might want to like make a little pocket for it to sit into. Again, this is a solid piece of material. Probably wouldn't recommend using a complete solid piece. If you look at some of the old robots that we made in previous years, we cut out all kinds of different pockets and made holes, and that's to reduce the material. So you might want to consider doing that. If that's the case, maybe open up that part by activating it, maybe make a sketch on that surface, and maybe look at maybe even projecting geometry. You know, remember, go to Create. You can, once you know your batteries are going to go there, you can always project the shape of the battery onto the surface. You can see that that shape is now projected. Give yourself a little extra room. You know, maybe draw a rectangle that's clearly bigger than the battery itself. You know, measure the battery, get a ruler, go out in the shop, measure it, make sure that it's going to fit. Put dimensions in. And again, this is just a demonstration. I'm not getting crazy with all the dimensions and everything, but you know, just making a simple pocket, something for it to sit into. My material thickness is 1/2 inch, so I certainly wouldn't want to go all the way through, but you can see now I've got a nice little pocket that battery can slip down into and can sit nice and neat. So there we go. If you can't see that, or if you're having trouble seeing things, remember, just turn off your... Ooh, looks like I didn't pick all of my regions when I extruded. You see that? You got to be careful when you're projecting geometry that you're picking all of the surface, or all of the profiles when you're extruding. So simple mistake. But again, hopefully this helps you to get started with your design and gets you moving. Of course, we're here to help. We're here to support. We're here to confuse, or whatever else you need. All right? Love it, and we're looking forward to seeing you guys do some really good things.